Ah, the ocean. It is vast, mysterious, and frankly, terribly inefficient. It's filled with wet, salty water that you can't drink, animals that want to eat you, and it takes hours to fly over. Have you ever stood on a beach, looked out at the horizon, and thought, you know what this place needs? A nice, flat, gray slab of pavement extending to infinity. Imagine the convenience. You could drive from Los Angeles to Tokyo without stopping. We could finally solve the housing crisis by zoning the Atlantic for condos. We could turn the Earth into the universe's largest, most depressing parking lot. So, let's do it. Let's grab our buckets and trowels and pour concrete into the ocean until it is flat, dry, and drivable. Spoiler alert, if you have a beach house, sell it now. And if you enjoy breathing air that isn't on fire, you might want to find a different planet. To understand why this is a spectacularly bad idea, we first need to appreciate the sheer scale of the enemy, the ocean. The total volume of water in the world's oceans is roughly 1.35 billion cubic kilometers. That is a number so big our monkey brains struggle to process it, so let's use a standard unit of measurement, the Olympic swimming pool. Actually, no, that's too small. Let's use the Grand Canyon. You could fill the Grand Canyon with water about 300,000 times and you still wouldn't be close. Currently, the human race produces about 4.4 billion tons of concrete per year. That sounds impressive, right? We build skyscrapers, dams, and bunkers with it. But if we diverted 100% of global concrete production to this project, and we started pouring it into the Mariana Trench today, filling the ocean would take approximately 300 million years. By the time we finished, the sun would have gotten hotter, boiled the oceans off anyway, and the human race would have evolved into crabs. We don't have that kind of time. We need to speed this up. Let's assume we have a magical supply chain. Maybe we open a portal to the dimension of infinite cement, or perhaps we just grind down the moon. We are going to pour concrete at a rate sufficient to finish the job in 10 years. Here is the first problem: displacement. You know that thing that happens when you get into a bathtub filled to the brim? The water spills over. That is Archimedes' Principle. Two things cannot occupy the same space at the same time. As we pump billions of cubic kilometers of concrete into the Pacific, that water has to go somewhere, and since we are pouring concrete into the bottom, the water goes up. Let's say we manage to pave the bottom 10% of the ocean. The sea level rises. Not by a few inches, like climate change models predict. We are talking about kilometers. By the time we have paved the Atlantic and Pacific basins halfway up, the displaced water has swallowed every coastal city on Earth. As we continue to pour, the water is pushed higher and higher, rolling over the plains, the forests, and the mountains. By the time we finish paving the ocean, to the level of the current shorelines, there are no shorelines. The continents are drowned under kilometers of displaced ocean water. We haven't created a parking lot, we've just raised the seafloor. The Earth is now a water world with a very thick, very smooth concrete bottom. The only survivors are people currently standing on the summit of Mount Everest, and they are going to be very confused when the sharks show up. This is unacceptable. We promised a parking lot, not an aquarium. To get a dry surface, we can't just displace the water. We have to consume it. Concrete is a mixture of cement, aggregate, which is sand and rocks, and water. The water triggers a chemical reaction called hydration, which turns the gray powder into hard rock. This is perfect. We don't need to drain the ocean, we will use the ocean as an ingredient. We need to dump enough dry cement and aggregate into the water to soak it all up. The ratio varies, but let's say we need roughly 1 part water to 5 parts dry mix to get a good, strong highway-grade slab. So, we begin dusting the oceans with massive amounts of cement powder. And this is where we run into the laws of thermodynamics. Specifically, the one that says energy cannot be destroyed, only changed into something that hurts you. The chemical reaction that turns soft cement into hard concrete is exothermic. That is science speak for, it creates heat. Have you ever touched a bag of concrete while it's setting? It feels warm, it's cozy. Now imagine that warmth scaled up to the size of a planet. The specific heat released by curing concrete is roughly 500 kilojoules per kilogram. When we mix the entire volume of the Earth's oceans with cement, we are triggering a chemical reaction on a scale that usually only happens inside stars. The energy released would be roughly 10 to the power of 26 joules. For context, that is about the same amount of energy the sun hits the Earth with the Earth in 1,000 years, and we are releasing it all at once. The moment our massive concrete pour begins to set, the ocean doesn't just get warm, it boils. But not like a tea kettle. The heat is being generated from within the mixture. The water that hasn't reacted yet flash boils into steam. This causes the wet concrete to explode. So instead of a smooth parking lot, you have a churning, boiling, exploding slurry of gray mud flinging itself into the stratosphere. The atmosphere, suddenly heated by this massive radiator, goes into hyperdrive. We are talking about hurricanes the size of continents. driven by the heat of a billion curing sidewalks. The air temperature spikes to hundreds of degrees. Any stick figures who survived the initial displacement are now being steam cooked. On the bright side, the humidity would be amazing for your skin, right up until your skin melts off. But let's say we survived the heat. We had super cooling fans from the Acme Corporation. We managed to set the concrete. We have done it. The oceans are gone, replaced by a flat, gray expanse of concrete 3,000 meters thick. Now we have to deal with gravity and isostasy. The Earth's crust is not a solid, immovable shell. It's more like a raft floating on a sea of molten rock called the mantle. This is the principle of isostasy. If you put a heavy weight on the crust, it sinks. If you remove weight, it rises. Water is actually pretty light, with a density of 1 gram per cubic centimeter. Concrete is heavy, with a density of about 2.4 grams per cubic centimeter. We have just replaced the water with rock that is nearly 3 times heavier. We have added quintillions of tons of mass to the oceanic plates. The Earth's crust screams in protest. The oceanic plates, burdened by this colossal new weight, begin to sink rapidly into the mantle. As they bend and crack, we trigger earthquakes that would register as an 11 or 12 on the Richter scale. These aren't just shaking the ground, these are shattering the tectonic plates. Levels of energy, but the mantle is incompressible. If the crust pushes down here, the magma has to go there. As the ocean floors sink under the weight of the parking lot, the pressure in the mantle spikes. The magma looks for an escape route. It finds the path of least resistance, the continents. While our new parking lot is sinking, the continents are being jacked up. Volcanoes erupt everywhere, not just the active ones. We're talking super-volcanoes popping up in Nebraska. The ring of fire becomes the ring of everything is on fire. So the ocean floor sinks, the continents rise and burn, and the stress fractures the concrete slab we worked so hard to build. Our beautiful, flat parking lot is now a cracked, jagged wasteland of broken concrete, sinking into the mantle, covered in lava. And we haven't even talked about the atmosphere yet. Remember, oceans absorb CO2 and produce oxygen. Plankton are the lungs of the planet. We just encase them in rock. The oxygen supply begins to plummet. Furthermore, the production of cement is actually a huge source of CO2. To make enough cement to fill the ocean, we would have to release more carbon dioxide than has been produced in the entire history of the Earth. The atmosphere is now mostly CO2. The greenhouse effect goes runaway. The surface temperature of Earth climbs to match Venus. It's 460 degrees Celsius. It is raining sulfuric acid. But hey, look on the bright side. The traffic is fantastic. There is literally zero congestion on the Trans-Pacific Highway, mostly because the tires melt instantly and the engines choke on the lack of oxygen. So, to summarize, if we try to turn the ocean into a parking lot, we will drown the continents, boil the atmosphere, shatter the Earth's crust, unleash a volcanic apocalypse, and suffocate whatever is left. It turns out the ocean is actually pretty useful exactly where it is. It regulates temperature, provides food, and keeps the mantle from squirting out in inconvenient places. Maybe we should just stick to paving paradise to put up a regular parking lot. It's less ambitious, but at least the laws of physics won't murder us for trying. Thank you for watching. If you enjoyed this hypothetical apocalypse, hit that like button before the magma consumes us all, and subscribe for more terrible ideas tested with science.